Hello dear students. Today we are going to discuss about linear discrete time systems. It is also called the LDS systems. So, what do you mean by a discrete time system? A discrete time system is a device that operates on a discrete time signals and that will produce another discrete time signals. So, the input discrete time signal is called excitation or input, and the produced discrete time signal is called the output or response of the system. So, let us picturize it. Let C of k is the output of a discrete time system and R of k is the input. So, the discrete time system has the system transfer function h, then the input or excitation is shown here and output is shown here. So, we can represent C of k or output of this discrete time system is equal to h of R of k. So, here h denotes the transformation or it is called the operator. So, this operator operates on this input and will produce as the output C of k. A discrete time system is said to be linear if it obeys the principle of superposition, and it is time invariant if its input-output relationship do not change with time. So, LDS basically refers to linear time invariant discrete time system, and in that case it will obey the principle of superposition and its input-output relationship does not change with time. When the input to a discrete time system is unit impulse, that is del of k, then the output is called impulse response of the system and it is denoted by h of k. Let h be the system operator, then we are giving the input as impulse and output is h of k. So, we can say h of k is the impulse response of the system. So, we can represent h of k is equal to h of del of k. So, a linear time invariant discrete time system or LDS system is characterized by its impulse response h of k. So, this impulse response is also called a weighing sequence. In doing some problems, you are asked to find the weighing sequence. So, you have to find out the impulse function or impulse response. So, that is the weighing sequence. So, the input-output relationship of an LDS system can be expressed by this formula. Here, C of k is the present output. So, it can be represented as minus sigma m equal to 1 to n am c k minus m plus sigma m equal to 0 to m bm r k minus m, where r of k represents the input and c of k represents the output. That it represents the present input and present output, but r of k minus m represents the past input and c of k minus m represents the past output, and here m is less than or equal to n. Next, we can represent the response of the LDS system as the convolution of the input and impulse response. So, the response of an LDS system to an arbitrary input R of k is given by the convolution of the input R of k with the impulse response H of k of the system. So, it is an important relation, that is C of k, that is output will be equal to input R of k convolution H of k, where H of k is the impulse response. That means when we are convoluting the input with the impulse response, we will be getting the output. Next is transfer function of LDS system or pulse transfer function. Actually, this is a question asked in the KTU university examination, that is explain about the pulse transfer function. So, what is a pulse transfer function or transfer function of the LDS system? Transfer function of the LDS system is given by the set transform of its impulse response. So, pulse transfer function is the set transform of its impulse response. Transfer function of LDS system is also called set transfer function or pulse transfer function. So, we can say let h of k is the impulse response of an LDS system, then its set transform is h of z, then we can represent this pulse transfer function is h of z. Okay. So, transfer function of the LDS system is the ratio of the set transform of the output of the system to the set transform of the input of the system. See, in the previous relation we know that C of k equal to R of k convolution H of k. When we are taking the set transform, this convolution will become multiplication, that is C of z will be equal to R of z into H of z. So here you know that what is pulse transfer function? Pulse transfer function is h of z. So h of z will be obtained by the ratio of c of z with r of z. So we can define the transfer function or pulse transfer function or set transfer function of the LDS system as the ratio of the set transform of the output of the system to the set transform of the input of the system. So let us see, this is transfer function of LDS system is equal to z of z by r of z, where c of z is the set transform of the output and r of z is the set transform of the input, that is shown here. Okay, so the pulse transfer function of the LDS system is obtained by taking set transform of the difference equation governing the system. So we can write the pulse transfer function as z of z by r of z, that is output divided by input, that is output set transform divided by input set transform, that will be in the differential equation, ratio of the differential equation form like this. Okay, so this is all about this linear time invariant discrete time system or LDS system and a pulse transfer function. Now we can do a problem that we will discuss in the next session. So these equations will be useful for you for solving the problem. Okay.